Interpretation of quantum mechanics. At the most fundamental level, the universe might not even decide what is real until it is observed. This is the bizarre world of quantum mechanics, and for over a century, scientists have been trying to decipher its true meaning. At the heart of this mystery lies the wave function, a mathematical description of all possible states a quantum particle can exist in. However, things get strange. A particle does not appear to choose a single state until it is observed. Before that, it exists in a superposition, meaning it is in multiple states at once. The moment it is measured, reality snaps into a definite state. But why? That is where interpretations of quantum mechanics come into play. Some physicists argue that wave function collapse is real, and that observation forces nature to select an outcome. This is known as the Copenhagen interpretation, the standard view for decades. Others reject this notion entirely. One alternative is the many worlds interpretation, which suggests that reality never chooses just one outcome. Instead, every possible outcome occurs, splitting into separate universes. In one world, Schrödinger's cat is alive. In another, it is dead. Once considered science fiction, this idea is now seriously debated. Another perspective, Bohmian mechanics, proposes that particles always have definite positions, but are guided by an invisible pilot wave. This interpretation makes quantum mechanics behave more like classical physics, just with a hidden layer beneath reality. Each interpretation presents its own paradoxes, and no consensus has been reached. If quantum mechanics truly describes reality, then what is reality? Does the universe only exist when we observe it? Age of the Earth. The Earth is ancient, but how ancient? Scientists estimate its age to be about 4.54 billion years. Yet, this question has been at the center of one of the most heated scientific and philosophical debates in history. For much of human civilization, people believed the Earth was relatively young. Ancient cultures, religious texts, and scholars often estimated the planet's age to be much less than what modern science suggests. Cause of autism. Science has established that autism affects how people think, interact, and perceive the world. But what actually causes it? That question has fueled some of the most heated debates in medicine and neuroscience for decades. The leading theory has been genetics, as studies show that autism tends to run in families. Scientists have identified hundreds of genes linked to autistic traits. However, no single gene causes autism. Some individuals with these genes never develop it, while others do, even without a clear genetic cause. This indicates that genetics alone cannot fully explain autism. This is where environmental factors come into play. Researchers have examined various possibilities, including prenatal exposure to toxins, viral infections during pregnancy, birth complications, and differences in gut bacteria. Some studies suggest that certain chemicals or pollutants might slightly increase the risk, while others indicate that maternal stress or nutritional deficiencies could play a role. The challenge remains. No single factor has been pinpointed as a definitive cause. Then, there is the controversy. For years, misinformation falsely linked vaccines to autism, a claim thoroughly debunked by decades of research. Yet, the myth persists, overshadowing real scientific inquiry into the condition. So, what is the truth? The best current explanation suggests that autism results from a complex interplay of genetics and environmental influences. Some scientists believe it is not just about risk factors, but about how the brain develops differently in early life. The real challenge is not just understanding the causes of autism, but also comprehending the diverse ways it manifests. If autism is not a single condition, but a spectrum of traits, how do we even begin to define it? Interpretation of quantum mechanics. Reality might not work the way you think. Cause of autism. Science has established that autism affects how people think, interact, and perceive the world. But what actually causes it? That question has fueled some of the most heated debates in medicine and neuroscience for decades. The leading theory has been genetics, as studies show that autism tends to run in families. Scientists have identified hundreds of genes linked to autistic traits. However, no single gene causes autism. Some individuals with these genes never develop it, while others do, even without a clear genetic cause. This indicates that genetics alone cannot fully explain autism. This is where environmental factors come into play. Researchers have examined various possibilities, including prenatal exposure to toxins, viral infections during pregnancy, birth complications, and differences in gut bacteria. Some studies suggest that certain chemicals or pollutants might slightly increase the risk, while others indicate that maternal stress or nutritional deficiencies could play a role. The challenge remains. No single factor has been pinpointed as a definitive cause. Then, there is the controversy. For years, misinformation falsely linked vaccines to autism, a claim thoroughly debunked by decades of research. Yet, the myth persists, overshadowing real scientific inquiry into the condition. So, what is the truth? The best current explanation suggests that autism results from a complex interplay of genetics and environmental influences. Some scientists believe it is not just about risk factors, but about how the brain develops differently in early life. The real challenge is not just understanding the causes of autism, but also comprehending the diverse ways it manifests. If autism is not a single condition, but a spectrum of traits, how do we even begin to define it? Interpretation of quantum mechanics. Reality might not work the way you think. Age of Earth. For centuries, many believed the Earth was only a few thousand years old. Even in the 17th century, James Ussher, an Irish archbishop, famously calculated that Earth was created in 4004 BCE, using biblical genealogies as his guide. This estimate was widely accepted in the Western world for a long time. Then, geology challenged this view. In the 18th and 19th centuries, scientists like James Hutton and Charles Lyell studied rock layers and fossils, realizing that the slow processes shaping the Earth, such as erosion, mountain formation, and sedimentation, must have taken millions, if not billions, of years. The idea that the Earth was far older than previously thought gained traction. A major breakthrough came with radiometric dating in the 20th century. By measuring the decay of radioactive elements in rocks, scientists determined the Earth's age to be about 4.54 billion years, with a margin of error of a few million years. This method has been repeatedly confirmed using different dating techniques, from lunar samples to meteorites. Despite this overwhelming scientific consensus, controversy still exists. Young Earth creationists reject these findings, arguing that radiometric dating is flawed and that the Earth remains only a few thousand years old. Meanwhile, some researchers suggest that our models of planetary formation may still be incomplete. So, is the Earth truly 4.54 billion years old? Almost all scientific evidence says yes, but what if we have only begun to uncover the deeper layers of the planet's history? Effectiveness of alternative medicine. Modern medicine saves lives, but role of chaos in nature. Everything around you, your heartbeat, the weather, the stock market, even the path of a single raindrop, follows one fundamental rule: chaos. At first glance, nature appears well-ordered. The planets orbit predictably, seasons change on time, and life follows cycles of birth and decay. However, beneath that order, chaos reigns. The smallest disturbance, a butterfly flapping its wings, a slight shift in ocean currents, can trigger a chain reaction of unpredictable consequences. This is the essence of chaos theory, the idea that nature is far less stable and predictable than we assume. Weather is a perfect example. Meteorologists rely on vast amounts of data to forecast storms, but beyond a few days, accuracy collapses. Even tiny fluctuations in temperature, humidity, or wind speed can send the atmosphere into unexpected patterns. It's not randomness, it's chaotic determinism. The system follows rules, but those rules are so sensitive that minute changes lead to vastly different outcomes. Some scientists argue that chaos is not merely a side effect of nature, but its driving force. It shapes evolution, climate patterns, and even human behavior. Without chaos, life might never have emerged. DNA mutations, random chaotic changes, fuel evolution. Unpredictable disasters reshape ecosystems, forcing adaptation. Chaos does not destroy order, it creates it. Not everyone agrees. Some physicists believe that even the most chaotic systems are simply highly complex but ultimately predictable. If we had enough information, they argue, we could foresee every outcome. Others counter that true randomness exists, that some things are inherently unknowable. So, does chaos mean nature is fundamentally unpredictable, or are we merely missing the deeper patterns hidden beneath apparent randomness? If the universe itself was born from chaos, does that mean we live in an unpredictable world, or one that only seems that way until we learn to decipher its patterns? Causes of neurodegenerative. Cause of neurodivergent diseases. What if your own brain was working against you, slowly unraveling everything that makes you, you? Neurodegenerative diseases, like Alzheimer's, Parkinson's, and ALS, are among the most terrifying conditions known to science. They strip away memory, movement, and identity itself. But despite decades of research, we still don't fully understand what causes them. Are they the result of genetics, environmental exposure, a fundamental flaw in how the brain ages? The truth is, we're still piecing together the puzzle, and every answer only seems to bring more questions for years. Scientists believed misfolded proteins were the key culprit in diseases like Alzheimer's. Clumps of beta-amyloid proteins build up in the brain, choking neurons and disrupting communication in Parkinson's. It's Lewy bodies in ALS, it's TDP43. But here's the problem. Not everyone with these protein buildups develops the disease. Some people's brains are full of these misfolded proteins, yet they remain cognitively sharp. So if the plaques aren't the sole cause, what is another theory points to inflammation, the brain's own immune system turning against itself, attacking neurons instead of protecting them. There's also mounting evidence that viruses, gut bacteria, and even exposure to pollutants could be long-term triggers, slowly damaging the brain over decades. And then there's the most unsettling possibility that neurodegeneration isn't caused by one single thing, but a combination of genetic predisposition, environmental triggers, and biological processes. We don't yet understand if we can crack the mystery of what truly causes neurodegenerative diseases. We could change millions of lives. But what if the answer isn't just one thing, but everything at once? Causes of autism. Autism is one of the most misunderstood conditions in effectiveness of alternative medicines. What about alternative medicine? Some say it's a natural, holistic approach to healing that pharmaceutical companies don't want you to know about. Others argue that it's nothing more than pseudoscience, preying on desperate people looking for hope. The debate over alternative medicine is one of the most heated in the world of health and science. Alternative medicine covers everything from herbal remedies and acupuncture to homeopathy and energy healing. Many traditional practices like Chinese medicine and Aida have been around for thousands of years, far longer than modern pharmaceuticals. Supporters claim that these treatments work in harmony with the body, treating the root cause of illness rather than just symptoms. But here's where things get complicated. Scientific studies have tested many forms of alternative medicine, and the results are mixed. Some, like meditation and certain herbal supplements, have shown real benefits. Others, like homeopathy, which dilutes substances until not a single molecule remains, are scientifically implausible. The biggest issue: many alternative treatments haven't been rigorously tested in controlled clinical trials, making it hard to separate placebo effects from real efficacy. ICS argue that relying on unproven treatments can be dangerous. If someone chooses herbs or energy healing over chemotherapy for cancer, the consequences can be fatal. But on the flip side, modern medicine doesn't have all the answers either. Alternative therapies often step in where conventional treatments fall short, especially in pain management and mental health. So, does alternative medicine work? The answer isn't simple. Some treatments have merit, others are outright scams. The real challenge is figuring out where to draw the line between ancient wisdom and modern science. Should we be more open-minded or more skeptical? Origin of language. If you're watching this, it means you understand